This is a video to help to understand the lesson that's on families of functions. And so first of all, we talk about f of x, some function, and it's some family. So we're talking about the main function that it is. So we could say x squared or absolute value of x or x cubed or something else, but it's just like it's the base of what it is, the beginning of the family. Well, we're going to add to that function. So instead of being x squared, it could be something like x plus 2. We're adding to it. Instead of just absolute value of x, it could be absolute value of x plus 6. Or instead of just x cubed, it's x cubed plus 54. And what that does to the graph of the function will move up c units, whatever it is that you were adding. So in this case, it's going up 2, it's going up 6. In this case, it's going up 57 units. So here we have an example of an absolute value function. It looks like a v, and what we're going to look at now is we're going to look at when we add 4. So what we're going to do is we're going to take the function and we're going to move it up 1, 2, 3, 4 units, and we're going to leave it there, and that is moving that function up c units. For another way we can translate these functions, we're going to look at a family of functions and look at the same ones. And this time, instead of adding some c, we're going to subtract. So we've got minus 2 and minus 6 and minus 57. And what that does is it moves this graph down c units. So once again, we have our absolute value function. And this time, let's do f of x. We've got f of x minus 3. So we're going to grab the function and we're going to move it down 1, 2, 3 units. And that is where the function now lives. It goes down 3 units. So we've moved the family down 3 units. In this next translation, notice that we're saying the input is changing, not the function. This time it is the input, x plus c. So instead of x squared, we have x plus 2, quantity squared. Instead of just the absolute value of x, we have the absolute value of x plus 6. And here, instead of just x cubed, we've got x plus 57 cubed. And this does pretty much the opposite of what you'd think, that it's going to move the graph to the left. So it's going to move it to the negative direction. Even though this is adding, it always goes the opposite of what you think, and so it's going to move to the left c units. So once again, we have our beautiful absolute value function. And let's look at when we add 2 to the input, what that's going to do to our function here, whoops, sorry, just a minute, is I got to grab the function and I'm going to move it back 1, 2, there we go, sorry, moved it back 2 units to the left. For this next translation, we're going to subtract from the input. So it's very important that we're noticing this time we're subtracting from that input. So we would have something like x minus 2 quantity squared, x minus the absolute value of x minus 6, minus 57. We're subtracting from the input. And this is going to make the graph of the function move to the right c units. So once again, our lovely absolute value function. And let's look at when we're subtracting 3. When we're going to subtract 3, grab my function, and I'm going to go 1, 2, 3 units to the right. And that is where this function now exists. It moved the whole function, the entire family moved those 3 units. Besides moving a function up or down or left or right, we can also look at how it affects tables of values. So we have some problems in your homework. We have tables of value, and in this you're going to be, it said to how does the table value change when you're going to go down 1 unit? Well, to go down 1 unit means to take the f of x and subtract 1. So for each one of those values that were in this table, I'm just going to make each one of them go down 1 unit, and so this would be the new output values in a table. Oops. Let's just ignore this part of it right here. Sorry, I'm trying to do this fast. If it has an equation, and I'm asking you to, with an equation, write me an equation of a function that goes 4 units up, well, we'd write the function f of x plus 4, and this would be going up 4 units. The next one is if we want to name the translation of a function. This is the function x squared, which is going to be a parabola, and graph it. So this was the equation that we were given, and we're supposed to name what happens to x squared. Well, and this is wrong. Hold on just a minute. sorry, I had that marked wrong. It's going to move each and every one of the points to the left 1 unit. So if we look at the original x squared, it's a beautiful parabola. This is about as good as I could do here. And every single point on that parabola is going to move over. So I marked 5 points that are on that parabola, and each and every one of them is going to move over. And in fact, all the other points in between there are going to move over 1 unit. So if I grab the parabola, if I grab the parabola, and then I move it 1 unit, the entire parabola 1 unit to the left. And that's what, you obviously, you'd have to just redraw it over there. You can't just magically make your paper do that. But that's going to be the translation of it. Let's look at some other things, though. This was a case of where I have a multiplier. And you can see what I've done is I made a table of values. Here would be if I had just looking at this the right side of the parabola, that if my inputs were 0, then 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Don't forget that -1 would give me 1, -2 would give me 4, and -3 would give me 9, which just gives us the mirror image, the symmetry that we have of the parabola. But if I were to multiply this parabola by 1/3, that would mean that each one of these outputs would be multiplied by 1/3. So the points that are on this parabola would get moved over in this way, and we would then have the parabola that look in this way, which is considered, it got wider, or it is a horizontal because we're stretching it out in the horizontal, so it's a horizontal stretch. If, on the other hand, instead of 1/3, I multiplied it by 4, a larger number, well, again, we have our table of values. If we multiplied each one of those outputs by 4, we're going to get really, really large. As you can see here, these numbers get large really quick. In fact, I can't even graph them all. And so again, this is a stretch, but instead of a horizontal stretch, it's a vertical stretch because it stretches right off the graph here, stretches it up. So these are some of the transformations with families of functions.